Today we're going to be talking about generating images from a video. In this case, what I needed to do was get a lot of data very quickly to play with a generative AI network. And it hit me that one of the easiest ways to do that would be to take a video, in this case I used a video of people, and extract a certain number of frames from that to turn it into a series of images that I could use to train the generative network. Now, what we're doing today won't work as labeled data. It's not going to work if you're trying to train an AI to recognize things, but if what you're trying to get is many samples of a particular type of data, and you have that in video, then this might be useful to you. So you'll see I've got an IDE and a terminal up because this is going to be a terminal application. You could obviously write, a UI for it or run it directly from your IDE, but this is how we're going to do it today. For inputs, I have a .mov file. This will also work with MP4s and I'm sure some other formats, but this is what I have today. And this is just a video I took on a recent hike in the woods to use for this video. So, to start with, we are going to get rid of the default information that IntelliJ gives us here. And I'm going to import a few libraries. We're going to import sys. We're also going to import CB2. And we're going to import OS because we're going to be using all three quite a bit. So the first thing we need to do is take our file name. And you're going to find I'm a big fan of running code early and often. So this is not going to be one of those videos where we type out the whole thing and run it the first time and everything's perfect. We're going to take many steps through the process. And I find that's both more useful to make sure we don't run into typos or any mistakes, and it's also a better way to learn the content. I would recommend that you type this along with me and run it as often as I do or more often. So the first thing we need to do is take a file name. So we're going to say file name equals sys.argv1. And that's basically just saying that we want the first element of the argument chain. So why don't we want sys.argv0? Let's actually try that, and I'll show you what that gives us. So I'm going to print file name because that is just the easiest way to see what's going on here. So I'm going to say python main.py. And I'm going to run this MOV file. And you'll notice what it printed was main.py. So in this scenario, the first argument is actually the Python script itself. So what we want in this zero indexed array is we actually want number 1, which is the second argument. So I'm going to put that in, print, and now we have our .mov file. So there are going to be several things I need to name throughout this video, throughout this code, and I don't want to call them, .mov. So one of the next things we're going to do is strip off that MOV and get our file name. So a few different ways to do this. Something we can do is pick a dividing line. I'm going to call that divider equals filename.find. And I'm going to say a dot. So it's going to find the index position of dot. If we print out divider, what that should give us is a number. Let's see. What did we mess up? Oh, well, it gave us exactly what we asked for. I let Windows autofill a dot backslash. Input validation is important, but for now, I'm just going to remove the faulty input. And we got number 15. So that is index number 15 in our file name. So here, I'm going to backspace over that. And we're going to say name equals file name. And we're going to take a slice. So basically, all characters up to divider is now part of name. And we're going to print name to make sure everything worked out well. And now we have our file name, so we can start to do things with it. And I'm going to start putting together some better input as we go through here. I'm going to print, do an F string here. Processing file name. All right. So we're going to be using CV2, which is a video and image processing library available in Python. We imported it up here. Down here, I'm going to say video equals CV2 dot video capture file name. You'll notice I'm not using name here. I am actually feeding CV2 the full name of the file that we're working with. Next, I'm going to do FPS equals video.get CV2.capprop. And next, we're going to print the frames per second. So print frames per second equals FPS. And again, all this so far is mostly for our own informational purposes. We're going to get some information from that file. So it's a .mov file. It was printed and it's was taken at 30 frames per second, or that's how CV2 is interpreting it, at least. So we're going to set frame number to 0. We'll talk about this later. Basically, we need an index position to start with. And then we're going to need to set somewhere to put all of the images. So I'm going to declare, and this is where we needed this name variable, because I don't want, just from a cleanliness perspective, I don't really want folder names with dots in them. Obviously, file names have dots in them. It makes things a little weird there. And I also don't want folder names with spaces, although we're not fixing anything about that here. So I'm going to say output dir is equal to name image output, and then we're going to create it. So the command is os.mkdir and output dir. Oh, I misspelled os, so it's giving me errors. So that'll actually work. That'll create a directory. But let me show you what happens. So first time runs great. I see there's now a video name underscore image underscore output sitting here. So if I run it again though, now my Python script fails. So anytime you're dealing with file system operations, sometimes network operations, it's always a good idea to either do some validation to make sure that the thing you're trying to create isn't already there, or to implement a try-catch to give you, a little bit more information and let it keep going in the event that it's already present. So I'm going to say try os.makedir output dir. Oh, I did not get a proper, there we go. It would have complained about that. And then I'm going to say accept, and we're going to print some information in the event of an exception. So directory output dir already exists or could not be created. So that tells the user, hey, the thing's there, or maybe it couldn't make it. And then obviously if they saw other errors later on, maybe they can go back and figure out, hey, it couldn't be created. But now our script can carry on. So we've got our output directory. We have read the video in with CV2 video capture. Now we get to start working through our video processing. So this is another place where, again, we're working with file system operations. So we're going to start with a try except, and when it eventually fails or finishes, it'll fire up the accept message. So I'm going to say try, and I'm going to go ahead and put an accept here. We can always put a pass in if you want Python to stop complaining. And I promise this will make sense soon. Completed writing frame number images. All right, so here we go. While true, and again, there are probably cleaner ways to do this. You could pull the number of frames that you wanted to extract and then extract that number. What I'm basically doing is saying, while there's a frame to extract, go ahead and extract it. And then, when something eventually fails, it's going to kick it out of the try block, hit the accept, and give you the number of images it wrote. This is not the cleanest way to handle it, but it worked really well, especially for a small script that doesn't need to be, fully production capable. We're just generating some data. So while true, we're going to say video.set, and this is where we're going to pass it a CV2 property, CV2.cap prop QS MSEC, and that's giving it the position, and then we're setting it to frame number. So we're basically saying, hey, set the video to the frame number that we're passing in, which starts at 0. So it's going to start at 0, and then it's going to iterate through the frames. So we can say ret and frame equals video.read. So that's going to read the current frame. So we've set the frame, we're reading the frame, and now we need to actually write the frame. So we're going to say cv2.imWrite, and we're going to say /name. Actually, we could just say output dir here. I don't have to spell it out again. /name. And let's name our frames after the image just so we can work with them a little bit more easily later. We're going to say frame number. So for each frame number, we're going to generate an image, and then we're writing frame. Remember, we got frame right here from video read. And then finally, we can say frame number plus equals 1. So basically, go through, grab each frame, and then increment the frame number as we step through. So let's see. We've written a lot of code there. So let's try it out and see what happens. All right. So directory already exists or could not be created, and then it launches into writing our images. So obviously this isn't showing us a whole lot. I will navigate to where this is. I'm going to Control C. So it completed writing 57 images. I'm going to go to this folder visually, and we can see what's going on here. So, just looking at a couple of these. So here's a picture of the woods. Very enthralling there. And another picture of the woods, and another identical picture of the woods. Now, other than the fact that this isn't going to change a whole lot because the whole video is basically just the same scene, you may have noticed that these are almost identical. And that's because at 30 frames per second, we are effectively generating 30 images for every second of this video existing. So in our 57 images, only 2 seconds have passed between image 0 and image 57. So the first time I did this, I started with this just one image per frame. A short video, about 10 minutes, hit roughly 70 gigabytes of data before I finally gave up and killed it, and then came back around to make it a little bit more efficient. It also gave me a bunch of images that weren't really all that useful, because if you're trying to feed your network a bunch of different data, you don't really want 300 images that are just 4 seconds apart in content, unless things are changing very, very quickly. So something we can do, an easy way to kind of back off that number. First off, let's just get back to our location, and I'm going to get rid of this directory so that we can have something fresh. So one of my favorite things to do in Python, if I'm trying to only do something every so many times, is use the modulus operator. So the modulus operator is looking for the remainder after a division operation. So what I can do is I can say if frame number modulus 1000 equals 0. So basically, hey, if frame number divided by 1000 has a 0 remainder, then run this. And that lets us, kick things off every 1000 frames. It would also be useful, hang on, we've got to edge this over. We still want frame number to increment every time. Otherwise, we're just going to do the same thing, only much slower. It would also be useful to have some output. So I'm going to say if frame number, and what can we do here? I don't think we want something every 1000. Let's do every 10,000. So if frame number modulus 10,000 equals 0, so every 10,000 steps, print, let's do processed frame number, and we're going to have to do a little bit of math here. So we're going to say divided by 1000. Because remember, every 1000 frames, we're processing an image. So image count will be frame number divided by 1000 images. And then we should also come down and do the same thing down here. Otherwise, the count at the end will be much longer than the one in the middle. All right, that all looks pretty good. Let's give it another shot. Ooh. All right, now we've got some output. So process 0 images, process 10 images, and it's going to sit here and give us status updates while it processes the video. And we can come in behind it and take a look at what it's starting to print. So now, while things do still look very similar, because again, it's all the woods, we are getting, there's some blur. We're getting different images because we're only taking, a capture every few seconds or every 1000 frames, instead of taking one every single frame. And that is really it. You've now got a folder of images that are being created from a video. It would be relatively simple to throw this whole thing into a loop if you wanted to process many videos and get a broader array of training data. So good luck with your data generation and your own AI projects.